Hey Math 8, today we are doing 4.4, which is linear functions. So 4.3 was functions. Today we're doing specifically linear functions. All right. So we're going to go ahead and drop all the way down to example 1 here on page 296. Okay. And we're going to look at this example 1. So the school store sells book covers for $2 each and notebooks for $1. Tony has $5 to spend. The function y equals 5 minus 2x represents the number of book covers x and notebooks y she can buy. Graph the function. Interpret the points graphed. All right. So you'll notice right here with this table, this is the exact same thing that we did in 4.3 with functions, right? The only difference is now we're not worried about function notation. As a reminder, function notation was where we wrote it as f of x. This time we're not worried about it. We're just putting it in terms of y. So we have y equals 5 minus 2x. All right, they put a table here for our values of x. One thing that's kind of interesting for x is that we don't have any negatives. All right. The reason for that is that just wouldn't make any sense, right? She's not going to be buying a negative number of book covers for obvious reasons. Yeah, they don't even get to get into the negatives for that. So there's just kind of a little bit of common sense to a real world problem there that you wouldn't need to use negatives for this one. But they do use 0, 1, 2, and 3. And then all they do is they take that equation and then they plug in their x value each time for x in their equation. And then whatever their solution is, once they simplify that expression, that's what they put in for y. So for example, this first one, they've got 5 minus 2 times 0. 2 times 0 is 0. So then we're left with 5 minus 0, which equals 5. All right. They do that for all 4 through here. Okay. And yeah, that's how they do the table on that one. Yeah. You'll notice also that the y value right here is negative. Okay. As we talked about earlier, she can't buy a negative number of notebooks, right? That doesn't make any sense. Okay. So basically what that means is that she cannot buy 3 book covers. All right. But if we look at the graph, they went ahead and graphed this point even though she can't buy negative numbers. All right. Which is totally cool. Not a big deal. But you can see they graphed all the points. So they got the 0.05 right here. The 0.13 is right here. 2, 1. And then 3, negative 1. Okay. And then they even mention here she cannot buy negative amounts. So she can buy 0 book covers and 5 notebooks, 1 cover and 3 notebooks, or 2 covers and 1 notebook. All right. Those are her 3 options that she has. Okay. All right. So I'm going to have you go ahead and try out this got it problem here at the bottom of page 296. So give this problem A a try. Once you've finished that up, we'll continue on with the video. All right, so if you have resumed the video and you were struggling with got it problem A, I'm going to give you a little hint. All right, so the hint is to make a table first. All right, so if you've been struggling, do that. Try it again. See if you can get it now. All right, example 2 is very similar. This time it's not a real world example though. Okay, this time it's just looking at the numbers and the equation, and that's all we're working with. Okay. So they say step 1 for y equals x plus 2 is to just make a function table and then select your 4 values for your domain x. Okay. So they did that here. All right. Then you're going to substitute all of those x values in for the x right here. So you can see that here, 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 and here, that they've done that for each one. Okay. Then you're going to solve to find y. All right. You can see those additions pretty clearly. 0 plus 2 is 2. 1 plus 2 is 3, and so on. All right. The last step that they have, and this one's a little bit new, is that they went ahead and they put their ordered pairs. Sorry, I blanked for a second. Yeah, they went ahead and put in their ordered pairs. All right. So your ordered pairs, remember, always go in the form xy. So the first one, we have 0 and 2. So the ordered pair would be 0, 2. All right. They do that all the way down the line. And then that is it for their table on this problem. The second step that they go into is they go ahead and they graph each ordered pair. Okay, so you can see here all 4 ordered pairs. We've got 0, 2 is the first one, 1, 3 is the second one, 2, 4 is the third one, and 3, 5 is the fourth one. Those are just coming from this. All right. Pretty self-explanatory there. And then they went ahead and drew a line through their graph. All right. And that's really it for graphing these and making tables out of them. Go ahead and try out Got It Problem B. I won't make you do Got It Problem C, but I do want you to go ahead and do Got It Problem B just because it is really good practice for your tables and graphs. All right, after you finish that, we're going to go ahead and drop down to page 298. And then it's going to give you a few definitions. All right, so a linear function is the first one that they give you. All right, a linear function is just a function in which the graph of the solutions form a straight line. Okay, because of that, y equals mx plus b is a linear function. We talked about that a lot during chapter 3 because y equals mx plus b is linear. It's a straight line. I mean, that's pretty much all there was to that. Okay, so just another little piece of review. All right, and then we've also talked a little bit about continuous and discrete. This is the first time that the book talks about it, but I did talk about it with you a little bit closer towards the beginning of the semester. So hopefully you remember this a little bit, and this is a little bit of review as well. All right, so continuous can take on any value, and there's no space in between those values. All right, whereas discrete has space between those values, and we will review why that is here down below. All right, so example 3 at the bottom of 298 is a little bit of an example of that continuous versus discrete. All right, so it says each person that enters a store receives a coupon for $5 off his or her entire purchase. And it says write a function to represent the total value of the coupons given out. All right. So y is our total value. Okay. Whereas x is our number of coupons, or your number, not couples, number of people. Okay. So that leaves our function to be y equals 5x. Again, this is linear because it is in that same form, y equals mx plus b. You can see that if we add the 0. Also, it's in the form y equals mx, which is our direct variation that we've talked about. And again, direct variation has to be linear in order to be a direct variation in the first place. So there's our equation. All right, now the question with this is this discrete or is it continuous? All right. If we look at this example, okay, this is what's going to tell us if it's discrete or continuous. All right, our x value, which is number of coupons. All right, if you think to yourself, okay, can they give out maybe like decimals of coupons, okay? That's one where you're going to be able to tell if this is discrete or continuous, okay? Can they give out a decimal for a coupon? Well, let's look, okay? If they do 1/2 of a coupon, okay? Is that something that a company would give out? Would they give out half of a coupon? They might give a half off coupon, but they're not going to give you just 1/2 of a coupon, right? That would be silly. All right, so no, they cannot give you half a coupon. Because of this, there will be space in our graph. Okay, there will be space between values in our graph. All right, if I were to graph that, just to show this to you, here's 1, 2, and 3. Okay, and let's say this is 5, 10, and 15 for your Y values, okay? At 0 coupons, okay, and I should put that in. I should label my graph. All right, the x-axis is our number of coupons, and what do we say? Total value is our Y value. So I don't want to write this sideways, so I'm just going to do it like that. So when they have given out 0 coupons right here, their total value of the coupons handed out is $0. Okay. Then they give out 1 coupon, and total value is $5. Okay. 2 coupons, the total value is $10, and 3 coupons, the total value is $15. All right. Now, when you look at this graph, is there going to be anything here? No. Okay, there's not going to be anything right there. Okay, because they're not going to give out 1.5 coupons. Again, that's silly because they're not going to have 1.5 customers at any point, right? So we can erase that point. It also means you will not connect the line right here. Okay, there will not be a line that connects those points. Okay, so since there is space in between the values, that tells us it is discrete, okay? It does not continue on between the points, all right? That's a good way to remember it, okay? So if it continues on through the points, then it is continuous, all right? And I'll write that down real quick for you as well. So it continues between points if it's continuous. All right. And then discrete obviously is the opposite. It does not continue. Okay. So, as I said, this example would be discrete because we have the space in between the points, and then we do not connect the points with the line. So there's no line through the graph. All right. I know this is a lot of information to write down. It's just a lot of explanation, honestly, for something that isn't a whole lot, if that makes sense. Okay. So if it helps you to simplify it a little bit more, feel free to simplify it. These are just a lot of explanations of the same ideas. All right. All right. So example 4 and 5 are actually just the continuation of 3, which I actually went into when I was explaining that last part. All right. So there is really nothing else to explain here. If you didn't like my explanation of why that was discrete rather than continuous, number 5 will explain it for you. So you can also look at that if you want a different way of looking at it. Okay. And then once you are done with that, I want you to go ahead and go down to the got it problems. And I want you to try out all 3 got it problems, D, E, and F. But instead of doing 595, because that's rather obnoxious, I'm going to have you do just $6. Okay, so $6 per pound of nuts. Okay, hopefully that makes it a little bit easier. You don't need a calculator so much to try to figure out those cents because, like I said, that's pretty obnoxious. Other than that, that is it for this video. It's another longer one, guys, so sorry about that, but it's good information. Let me know if you have any questions, and then I will see you guys in class.